If you haven't read the question, please pause the video to do so now. In this question, we are asked to calculate the empirical formula of a compound based on the percent composition by mass. This is a classic question in introductory chemistry courses, and the key to solving the question is to assume that you have 100 grams of your sample. Now, you don't actually have to use 100 grams, but it's the most convenient number to use. And the reason for that is as follows. Let's take a look at part A first. If you have 100 grams of sample and 55.5% of that is potassium, you should be able to easily determine that the number of grams of potassium would be 55.5. Similarly, if you have a 100 gram sample and 14.6% is phosphorus, that's going to mean that 14.6 grams of phosphorus is present in your sample. In a similar way, we can determine that you have 30.1 grams of oxygen in the sample. At this point, we're going to convert the grams of each element into the moles of each element, and to do that, you're going to need your periodic table. So please take that out and take a look at potassium. See if you can figure out how many grams of potassium would be present in 1 mole. And you should be able to figure out based on the atomic weight given in the periodic table. So 39 grams of potassium corresponds to 1 mole of potassium. That's straight off the periodic table. Similarly, if you look up phosphorus, you should see that 1 mole of phosphorus is approximately 31 grams. For oxygen, we see that 1 mole of oxygen corresponds to approximately 16 grams of oxygen. Now, you'll notice that grams of potassium is in the numerator here and it's in the denominator in the next term, so that allows us to cancel the grams of potassium. Similarly, we can cancel grams of phosphorus and grams of oxygen. And if you take out your calculator, you can go ahead and calculate the number of moles of each element. And you should have obtained the following numbers. Now we're really only one step away from determining the empirical formula, because all we need to do is to convert these numbers into whole numbers. Now the mathematical trick for converting this set of numbers into whole numbers is to divide each one by the lowest of the 3 numbers. So obviously the lowest number of the 3 is the 0.47. So what we can do is divide each quantity by that lowest number, that 0.47. And that's always the trick to doing these questions. You're always going to divide by the lowest number of moles, never the highest or any other number. So after that step, you should have obtained the following whole numbers for each element. This was approximately 3, this one would equal 1, and this was approximately 4. So the problem is actually solved because we can use these numbers as the subscripts in our empirical formula. So for potassium, we have 3, phosphorus, we have 1. You generally don't have to write the 1 subscript right there, so we'll leave it empty under the assumption that there is a 1 right there. And then for oxygen, the subscript is 4. And there is your empirical formula. Part B of the question proceeds in a very similar way. And for that part, you should obtain the following answer. Part C actually has one little twist in it towards the end of the problem, so I'm going to solve that one in a separate video. But before doing that, let me correct that. That was not oxygen. That's supposed to be fluorine. So let's take a look at part C and understand what twist is present in this part of the question. I'm going to go ahead and set up the calculation in the way that we set it up for part A of the question. So here is the work that we did in part A, just applied with different numbers. You might want to pause the video and make sure you understand how to get to this point in the problem. But after dividing by the smallest number of moles of each element, we see that oxygen has a fractional amount left over, and that typically arises in these types of problems. So we can't write an empirical formula with a fractional subscript, so we have to get rid of that fraction somehow. And the mathematical way of getting rid of that fraction is to multiply each one of these numbers by 2. So let's watch what happens when we do that. We'll go ahead and multiply each one by 2. And we'll obtain the following numbers. Now this is better because every number at the end is now in a whole number form, and that's how we want to write our empirical formula, is using whole numbers only. So the final empirical formula can be written as follows. And that is the answer to the question.